In this video, we'll be talking about implicit differentiation. By definition, explicit means clearly defined, and implicit is implied but not directly expressed. Some equations cannot be written in explicit form. For example, x squared minus 2y cubed plus 4y equals 2. If you tried to solve this for y, you wouldn't be able to. To differentiate this type of equation, use implicit differentiation. To differentiate a term that just involves x, the derivative with respect to x, notice these variables agree. So the derivative of x cubed with respect to x is 3x squared. To differentiate a term that involves y, if you're differentiating with respect to x, these variables do not agree. So we have to use the chain rule. So now we can find the derivative with respect to y of y cubed, and then multiply that by dy dx. Remember, these factors, this one and this one up here, are in positions where they could cancel if they were factors. So the derivative with respect to y of y cubed is 3y squared, but then we have that multiplied by this dy dx. So let's differentiate a few problems. We're asked to find the derivative with respect to x of x plus 3y. Now notice when we differentiate the first term, these variables agree, so the derivative of x is just 1. But then on this one, when we're differentiating with respect to x, this is a y variable, so we need the derivative with respect to y first, and then multiply that by dy dx. So we have 1 plus the derivative of 3y with respect to y is just 3, and then multiplied by dy dx. Let's do another one. Notice on this one we're differentiating a product, so we have to use the product rule. So we take the first function, x, times the derivative of the second function, and that one is a y factor, so I have to differentiate with respect to y, and then multiply that by dy dx. Plus, and then the second one, times the derivative of the first one, and that's with respect to x, and it is x, so I'm fine. I don't need to use the chain rule on that one. So here we have x times the derivative of y squared with respect to y is 2y times dy dx plus, and then y squared times, and then the derivative of x with respect to x is just 1. So this derivative is 2xy dy dx plus y squared. Do one more. The derivative of our first term here with respect to x, this is a y term, so I need to use the chain rule on this one. So the derivative with respect to y of y cubed gets multiplied by dy dx. Here we have a product, so we need to use the product rule. So the first factor is negative 4x multiplied by the derivative of the second factor, which is y. So we have the derivative with respect to y of y multiplied by dy dx plus, and I'm running out of room, so I'm going to come down here. The second factor times the derivative of the first one, and it's just an x term, so derivative with respect to x. And then on this one, it's just an x term again, so the derivative with respect to x of x cubed. So my derivative is, the derivative of y cubed with respect to y is 3y squared multiplied by dy dx minus 4x times the derivative of y with respect to y is just 1 times dy dx plus y times the derivative of negative 4x with respect to x is negative 4 plus then the derivative of x cubed with respect to x is 3x squared. So we can simplify just a little bit because of this multiplying here. We have 3y squared dy dx minus 4x dy dx minus 4y plus 3x squared.